Now, moving beyond solving systems of equations, whether it be graphically or algebraically, is being able to solve systems of linear inequalities. Now, if you'll recall, when we have a system of linear equalities, something that looks like this, it shows up as a half plane. So when we have our coordinate grid and we graph our line on it, we result in not only the items that are on this line, but half of the Cartesian plane along with it. In this case, we're looking at the items that are greater than our boundary line. So we're looking at things that fall above it, above and to the left. However, when we're working with a system of linear inequalities, we're not looking for a single point as we do when we have a system of linear equations. We're looking for where the two half planes overlap each other. And everything that falls within that boundary becomes part of our solution set. So let's do a couple of these as practice so you can get a feel for what it's like before moving on and doing some on your own. So here we have y is less than a negative 1/2 x plus 1, and y is less than or equal to a negative 4x plus 3. So what we're going to do is graph each of these on the same set of axes and see where their areas overlap. Show you some shortcuts and secrets for being able to do that. First, let's do y is less than a negative 1/2 x plus 1. So we're going to plot this, use the dotted line, and we're looking for items below. So here's our line, and as I said, we're looking for items below it, so I'm going to put a couple of small arrows pointing down to remind me of that. Next, we have y is less than or equal to a negative 4x plus 3. So when we put that in, and again we're looking for items that are below this or down to the left, so I put these arrows, and my area of overlap is everything that falls within the shading of both of those. So we have the boundary that are set up by the two different inequalities, and it's everything in that lower left-hand corner of the intersection. So we're graphing each line individually. Now, if you have multiple sets of colors that you can use for your graphs, please feel free to do them and look for that overlap. Otherwise, just emphasizing the area where the overlap is by only shading or coloring in that part becomes very useful for helping people observe and visualize what's going on. Let's try the next one. X is less than or equal to a negative 3. Now, reminder, anytime you have only one variable in your equation or inequality, we are looking at either a pure vertical or a pure horizontal line. So here we have everything less than x being a negative 3. So I'm just going to draw in my negative 3 line, and less than will be to the left. Then y is greater than or equal to 4/3 x plus 1. So plot that line, and we're looking for items that are greater than, so up from here. And what we will have is this area of overlap. And since both of these have the equal option, we do include our boundary. So including or excluding the boundary becomes another point of question to look at. Now we're having to do it with more than one at a time. So I'd like you to have some opportunity to practice a few of these on your own. Try out these two systems of linear inequalities. Pause the video for a few minutes, try these ones out, and then check back to see if you're correct. So here are your solutions to these. We have the left-hand quadrant in the first set and the upper right-hand quadrant in the second set. So hopefully you're able to figure these ones out and get graphs that looked close to this. Applications to these work in an item called linear programming, where you have a certain example, you have a certain amount of time to use and different activities to fill that time with. How can you best use your time? So applications abound. Just interested here in learning how to do the basic activities. So look over this, review the video as much as needed, and we'll move on from solving systems of equations and inequalities.